Hey guys, Mr. Delos here, and I'm going to talk to you a little bit today about reference points and specifically reference frames. So I'm going to first talk about reference points and reference frames in context of position and displacement. So I'm going to start off with that. So let's first figure on reference point. A reference point is a point of reference, a point that you will always refer back to. And so here I've got some markings on this wall, and the one right down the middle I'm going to choose to be my point of reference, my zero position actually. So there's my zero position. And so just to keep it in context from your point of view, I'm going to make it so that way going to the right is going to be a positive direction. But that's not a point of reference issue. Well, that's a reference frame issue. So I'm going to go one step. Steps are about a meter, but I've actually made pretty small steps here. And so if these are positions 1, 2, and 3, then of course if I go in the other direction it should be positions 1, 2, and 3, but with the caveat. So those will be negative 1, 2, and 3, and those are my positions. So I'm going to real quickly kind of demonstrate through and go through a couple of scenarios. And so take a look. Take note of where I start and where I finish. I'm going to ask you what at any point in time, what my current position is, what my distance covered was, and what my displacement was. So I'm going to start at my reference point, my zero position. So what is my current position? My current position is the positive 1. Be specific. Positive, not negative. What is my distance covered? Well, say I went 1, 2, and then I went back 1. So I actually took 3 steps. If I was driving a car, it's my odometer, the distance reading on your dashboard will tell you how far you've gone. That's your distance. What was my displacement? My displacement was, by the time all was said and done, I traveled 1 step in a positive direction. That's my displacement. Let me try something else. This time I'm not going to start at my zero position. Instead, now I'm going to start at a negative 1 position, and so watch what I do. So my position is actually at the reference point. It's just the place that I always refer back to. And so, position of 0. My distance covered it really was the same action that I did before, isn't it? So my distance covered is still 3. I went over 2 and then back 1, a full distance of 3 steps, or 3 meters, but steps really in this case. Steps can be a unit, sure, why not? And then my displacement, again, also, I finished positive 1 steps compared to where I started, so my displacement is positive 1 steps. And so my reference frame is the fact that that direction is positive and that direction is negative. And my reference point is that particular position. Of course, this is linear, and you can complicate it by making it a 2-dimensional or 3-dimensional system. In fact, a good sort of 2-dimensional system might be the globe, the Earth. We do have reference frames and reference points for each of the 2 dimensions of Earth's surface. So think for a second of what those are. So the reference points would be the equator for the north and south, and it would be the prime meridian for the east and west directions. And of course, I kind of already told you what the reference frames are. East-west is the directionality for that dimension, and north-south. And so that's sort of a reference frame issue. But reference frames, I'm going to now get into sort of how reference frames will be a bit more relevant to us in AP Physics. or doesn't have to be AP physics, just any physics whatsoever. So reference frames are an issue of what is moving relative to what. That is also a reference frame issue. So, for example, the camera here is stationary, and if you see me moving, for example, 1 step per second, so I'll start here, and for every second that goes by, 1, 2, 3, or so on, so I'm moving about a step per second, and you see me moving relative to the wall, moving 1 step per second. Relative to the camera, I'm moving 1 step per second. However, if the camera moves with me, relative to the camera, I'm not moving at all. To the wall, I still am. So it really quite depends on the reference frame. Am I in a stationary reference frame? Is the camera moving? What am I moving relative to? If I am walking at 1 step per second in a negative direction, but I'm walking on a conveyor belt that's going in that direction at the same rate, then the camera is only going to see me just doing one of these moves. And so my velocity relative to the wall and relative to the ground would be 0. Or if I'm on a conveyor belt that's moving in that direction, you know, think of a treadmill, some sort of conveyor belt that you might have at the airport. That's always fun for me. And so if I'm on a conveyor belt going that way, that's 1 step per second, and I'm walking that way at 1 step per second, then I'm going to be moving pretty fast in that direction. It's going to be 2 steps per second. So am I moving at 1 step per second relative to the conveyor belt? Or am I moving the 2 steps per second relative to the stationary ground? That's a reference frame issue. Reference frames become even more relevant when we start talking about circular motion, because are you in a stationary reference frame? Are you comparing your velocities to something that is stationary? Or are you, for example, are you in the back of a truck, in the back of an 18-wheeler truck, where all of a sudden you go flying up against a wall and you freak out for a second because you didn't even realize that the truck was moving, and you go, oh my, the truck driver must have slammed on the brakes, making me hit this wall. But did he? Maybe you just were disoriented. And in fact, the truck is going that way, and he slammed on the gas, and the back of the truck accelerated towards you. You don't know which one. Or what if I'm coming towards you and the truck driver turns the wheel to that direction? The wrong way. I want to keep hitting that wall. So he turns that way. Okay? He turns the wheel in that direction. Then that wall is going to accelerate into my path. And frankly, all 3 of those scenarios, I do not know which one is occurring. I don't know if the truck driver is braking, accelerating, or turning. And in fact, in truth, all 3 of those scenarios are an acceleration. You have 3 accelerator pedals in any vehicle. Gasoline, you know, the gas pedal, the brake pedal, and the steering wheel. So, reference frame. Reference frame can be taken in a couple different ways. What is your directionality? And are you in a moving reference frame, which is really important moving forward for us? Reference points. What point are you referring back to as your comparison position? And so that's my quick lesson on reference frames and reference points. So hopefully that got across. See you next time. Have a good one.